let's take care of this power series. I want to determine the interval of convergence and radius of convergence. So first of all, in this series, I decide to use the ratio test. So the ratio test, I have to determine an, which is the given series, 4 to the n divided by root n, and then times x to the n, and then the next term is an plus 1. That is a negative 1 raised to n plus 1, and then 4 raised to the n plus 1 divided by the square root of n plus 1. You change all the n to n plus 1, and then x raised to the n plus 1. And then we have to simplify the an plus 1, not simplify, expand to make our next step more convenient. So n plus 1, the top you have negative 1 raised to the n, negative 1 raised to the first, 4 raised to the n, 4 raised to the first, x raised to the n, and then x raised to the first. All right, and then you do your ratio. So limit as n approaches to infinity, we can set up a ratio an plus 1 divided by an. The reason we use an absolute value is because we want to take away the alternating, the plus and the minuses. So that is limit as n approaches to infinity. We have negative n, negative 1 raised to the n, negative 1, and then 4 to the n, 4 to the first, divided by the square root of n plus 1, x raised to the n, x raised to the first, and then multiply the reciprocal of an, that is square root of n on top, and then everything else on the bottom. 4 to the n, and then x to the n. There must be a few cancellations, so negative 1 raised to the n, 4 raised to the n, and then x raised to the n. All right, that's it. So we go back to the problem. So we have some square root left. So we have the square root of n divided by the square root of n plus 1. And then also the negative 1 raised to the first, that is a negative 1, but we have an absolute value. So that negative 1 is just a 1. We can ignore that. And then we also have a 4. We cannot ignore the 4. And what else? A 4x, right? So the 4x, I've just put it right here. And then we have limit n approaches to infinity. We will use a big square root, n divided by n plus 1, and then 4x. So inside the square root, the radicand, what do we have in there? So we have the highest degree is 1, right? So we will divide each term by n raised to the first power. And then we go back to the problem. So we have limit as n approaches to infinity. So we have the top, we have a 1, the bottom, we have a 1 plus 1 over n, so the fraction becomes 0, 4x. So overall, we have the square root of 1, which is a 1, square root of 1 times absolute value of 4x, so that is just 4 times the absolute value of x, right? 4 is always positive, so you can take that out of the absolute value. And this must be less than 1. Why? Let me just say why do we do this? So to make the series converges. Why do we have to do that? Why do we have to do a less than 1? The reason is because, do you still remember the power series? The power series is x raised to the n, right? So this is actually a geometric series where we have a common ratio raised to the n power. So in order to make the geometric series converge, the absolute value of the common ratio must be less than 1. So that's why we must have the whole thing less than 1. That must be a 1, not 2, not 3, not a 10, not 11, not 1,000. It must be less than 1. The 1 came from the idea of geometric series. That must be less than 1 to make the series, to make the geometric series converges. All right. And then we solve the inequality for absolute value of x less than 1, divide each side by 4, and then that is negative 1, 4, less than x, and then less than positive 1 over 4. So first, and then we have to test each n, right? So let's test the positive when x is equals to 1 over 4, and then you plug the 1 over 4 into the power series. So you have negative 1 to the n, everything that doesn't change the n, right? And then square root of n, that changes this, 1 over 4 raised to the n. And then we have a 4 and a 1 over 4, so I'm going to do this. So n goes to 1 to infinity, negative 1 raised to the n divided by square root of n. And the 2, 4, I will just put it like that because they are both raised to the n power. So that will be gone instantly, right? The 4 divided by 4 is just a 1, so the n doesn't matter. And then the leftover is just an alternating series. So we have a negative 1 to the n divided by the square root of n. So this is an alternating series. And then you have to use the alternating series test. You have a Bn, which is 1 divided by n, root n, and the Bn plus 1, you change the n to n plus 1, and then you prove those two conditions, they must be true in order to say the series is convergent. So first, we have to show that a Bn plus 1 must be less than or equal to Bn. So when n is equals to 1, we have 1 over root 2 that must be less than or equal to 1 over 1. All right, so that is true. Okay, and then we have number 2, we have to prove that the limit as n approaches to infinity of Bn is equals to 0. Infinity, 1 divided by root n equals to 0. So 1 is true, 2 is true. That means the series is convergent using the alternating series test. So that is only the right endpoint. We also have to test the left endpoint, the negative 1 over 4. Let's do that. That is why the problem is so long. The testing is long. So when x is equals to negative 1 over 4, so we change the x to negative 1 over 4. So let's copy everything else. And then change that to negative 1 over 4 raised to the n. So here we have the 4 raised to the n, right? So we play a little trick using the law of exponent. Negative 1 raised to the n divided by root n. And then here is how we play. 4 divided by 4 raised to the n. And then what do we get? This one gives me a square root n equals to 1 this. Negative 1 to the n divided by root n. This is also a negative 1 to the n. So basically the two negative 1 to the n got cancelled. Think about this. When n is equals to 1 or n is equals to 2, negative 1 raised to a 2, negative 1 raised to a 2, they got cancelled, right? Not cancel is equals to 1. So overall, we have sum 1 divided by root n, so which is a sum 1 divided by n to a 1/2, then that is a P series. And then the power is 1/2 less than 1, then not too happy because when the power is less than 1, the series is diverged. So we have a diverge and then we have a converge. Now let's draw a summary. Negative 1 over 4. I don't like the mark. Negative 1 over 4 and past the 1 over 4. Negative 1 over 4 is diverged, so we use an open circle. Past the 1 over 4 is converged, so we use a solid circle. And then this is the interval of convergence, and then outside of the interval, the power series is diverged. So the interval of convergence is negative 1 over 4 less than x, and then less than or equal to 1 over 4. So the interval is this. Negative 1 over 4 and then past 1 over 4 square bracket. What about the radius? This is a 0, right? So half of the interval, the radius, is a 1 over 4. All right, so that is the end of this video. I don't want to put two power series in one video because that will make the video too long. So if you think my instruction is helpful, which is my instruction is helpful, trust me, give me a like, subscribe to my channel. Let me know in the comment section below what do you think. As thank you would be nice. I see you all in the next lesson. In the next lesson, we will take care another power series. See you there.